And if you ever use Microsoft Access, maybe, or PostgreSQL, or Microsoft SQL Server, it's just a language that's common among a lot of databases that provides a way for you to express what kinds of data that you want. And it's different than programming, and you don't need to tell the computer how to go get it. You more sort of declare what you want, and then the database figures out how to fetch it for you. So it is, like Max said, a kind of Excel on steroids. It can handle millions, billions of rows without breaking a sweat. Yeah? You will not, and definitely not today. I'll show you guys some tools in the next class where you can play around with this stuff. And then there are plenty of online things. I'll also give you access to Bright's SQL database. So if you want to practice your queries on there, you can. No, I set it up so that you can't screw anything up. I don't trust you. I don't trust me either.
Is that a challenge?
You can have to be my guest. So yeah, I'll give you guys all the tools that you need to play with this and try on your own in the next class. Cool. Anything else? Awesome. So the first thing is like, what is data exactly? And I'll give you like a few examples to start. So 4 is a piece of data. Stephen is a piece of data, and a date, January 1st, 2016, is a piece of data. Okay, data is not that useful by itself until you put it into a context and to some sort of framework for understanding it. Okay, 4 could be the number of kilometers we are away from something. 4 could be the age of a person. So without the context, you don't really have any more than data. Okay, so if you take data and you add in the context for that data, then you end up with information. Okay, and information is what we care about. From information, you can derive knowledge, and which is, if you're analyzing any sort of database, that's your main goal, is to come up with some knowledge. So we're going to start with the very, looks like I didn't finish the slide. Some very basics. So that was the pieces of data. Now, what is a data model? A data model is basically just a context for a lot of pieces of data that you might have on hand. So, for example, I said we have 60 million rows of e-gauge data without knowing that that was minute by minute, and it referred to energy production and energy consumption. You have no idea what that data meant. So a data model is the combination of the database, how you structure your data, and then also how to interpret it. Okay? So usually it goes the other way around. Usually you have the model in your head, and then you put it into database form. Not that you just have like random data and you're trying to make sense of it. Unless you like happened upon this data source online, and I don't know when you would go that way. So one other important thing to note about a data model is that whenever you're designing how your information looks, you really can't make exceptions. Okay? If you don't have a column to capture what times and master signed up to Bright, for example, then there's going to be no way for you to track that. So whenever you're designing this stuff, it has to handle every single edge case. Another example, can the same person at Bright be the owner of 2 installations? I would say absolutely yes. Is your data model going to be able to handle that? Don't know. Did you structure it in such a way that you thought about this edge case before you designed what the data looks like? We actually probably got this wrong to start at Bright. We have a mapping 1-to-1 of a person with their installation. But how we get around that is we give them a different email address. And so we have a little hack around that in our system, but we could have designed it better to start. We didn't think through all the edge cases. Okay, so what are the building blocks of data? How many of you guys have used Excel or Sheets? Okay, how many of you have used another data tool? Anything, Access, any kind of SQL, anything else? Yeah, what was it?
Access.
Access? Follow?
Yeah, SQL.
SQL? SQL? Nothing? Okay. Yeah, there are also other like tools available. We are looking at some at Bright right now. One's called Looker, one's called Domo. You might have seen commercials on Facebook coming out for that. But pretty much they're all just interfaces on top of the same sort of data schema, built up from the ground. Okay, so for those of you who have used Excel, you know that you can type in numbers, you can type in like a bunch of characters, you can type in URLs, and it kind of just figures it out and shows it the right way. You can add different formatting to each individual cell to show this as a date, show this as a number, and telling Excel to interpret it different ways. While that's extremely flexible, it's not very good for your data. Okay, so if you have a person's age, it should probably be a number. If you have someone's name, it should probably not be a number, right? Excel lets you do that sort of thing. In a database, you want to be a lot more careful about designing. And so databases have a concept of a data type, okay? And there are some intrinsic data types, intrinsic to the world, I would say, and most computer systems. They are an integer, so any number, integer like you learned in school. A Boolean, how many of you know what a Boolean is?
It's a conditional.
Yeah, so.
Well, I know it.
Yeah, it's conditional. Yeah, true or false.
True or false, yeah.
So an integer can be 0, 1, 2, 3, -1, etc. A Boolean can only have two values, true or false. A real number, so just like in math, any number between 0 and 1 is a real number, any number in between any integer is a real number. And a character, this represents like a single character in a language, A, B, C, D, any sort of other character from other languages, Chinese, Korean, that have their own character sets. So those are kind of the building blocks. Then we have what you would call complex types. And they're built up of smaller, of these like intrinsic types. So a string, has anyone heard of a string before? Yeah, Max? Okay, a string is a very, very common type. I almost actually put it in the like intrinsic types. A string is a combination of characters. So for example, your name is a string. Stephen is a string of characters. It's actually a number of characters and also a length. You need to know where to stop that string. So it's a combination of an integer with characters. Date is another one. So you could represent date as an integer, as the number of seconds since year 0, as the number of nanoseconds, however, or a real number. But dates have a lot more that you might want to do with them. They mean more to people. You can't ask what day of the week is this second number from like year 0. It's very, very hard to do that. So to be a little bit nicer on ourselves, we invent a new type called a date. And a time. Time as well is what time of day is it? And this is important because it's not an instant in time, right? So where I experience at 8 in the morning in San Francisco is different when you experience at 8 in the morning in Mexico City. Okay, so is it a time? Is 8 in the morning is when I want my alarm to be set, for example. But a time for a meeting needs to have a time zone associated. So there are also different kinds of times. Is it a point in time, an instant, the same for everyone in the whole world, or is it a relative to your time zone kind of thing? So a lot of databases have these complex types because they are so common that you want to use them. They have a lot of use in almost every single situation. I don't know a data model I've created that didn't use any of these. What are some other ones can you guys think of? What are other sort of, think of like a column in Excel. What type of data is it? Any ideas?
Double currency.
A double? Yeah, double. I would put that as like real number, but yeah. Currency? Cool. You could probably represent currency with one of these. Like a real number perhaps, or an integer. But currency has special rules around it. And also pesos versus dollars versus euros. Yeah, exactly. Currency. Anything else? I'm sorry?
Personal.
Personal? Like a person?
All the people that you're representing.
Mm-hmm. Yeah, I would say that is a combination of types. I would say a person is it's a name, it's when they were born, it's the best way to contact them. So it's a combination of these things, but yeah, that is totally something that you'd like to model as well. Anything else? I know Brett uses more. Pablo, give me one.
Data type.
Data? Yeah. I'll give you a few more. So latitude and longitude is a really, really common one. A bounding box, basically like, are any of you ECs here? Yeah. So whenever you pick like the roof of the house, that's like a bounding box around. It's almost like four latitude longitude points.
Yeah.
Let's see. I had a few other ones here.
Dimensions could be, right?
I'm sorry.
Volume.
Yeah. There's a ton of this stuff. Country, state, those could be complex types. Null is a special one I'll talk about in a second, and enum is another special one I'll talk about. So basically, the designers of databases will pick out some of these complex types that they'd like to provide to whoever uses them. The ones that we'll do tomorrow do include latitude, longitude. They include like geometries, like paths around something on the globe. And let's see what else. It has a lot of extensions that you can add, download software to make your database more powerful. But for the ones that we don't have, so databases don't provide country and state, we'll have to build those. Okay, so we'll go through some examples of how to do that in the future. One special data type that's really important to point out is called null. In the previous slide, we talked about Boolean, which only has a true value and a false value. A null actually only has one value. It's just null. However, you normally apply it to any other kind of data. Okay, so you say, I have an integer that can also be null. Means you can have 0, 1, 2, 3, 4, 5, or empty. Okay, in Excel, this would be like a cell that doesn't have any data inside of it. It's just empty. This is useful whenever you have data that you want to structure that is missing, is like missing values. Or what's the birth date of this person? We don't know. You can't put a valid date into that field if you don't know. So this is kind of I would say it's lazy on the programmer or the data modeler to use null, but it is so practical that it's used all the time. So you can have a null state if you don't know, or a null country. You can have a null name. You can have a null anything. So it's kind of a data modifier. You can say this piece of data can be null or not. Does it make sense? Mm-hmm. Cool. And then the last piece is in enum. That's short for enumeration. Enumeration means a collection of values. And we have a few enumerations in Bright. Let me see if I can find some of them. Okay, so one of the enumerations that we have in Bright is an AMBI referral source. It's the projector turned off. The slides aren't super
it's coming back on.
important.
Sorry.
Out of the class. Okay. Sorry.
It's okay. So an example of an enum in Bright would be an ambassador referral source. So ambassadors can come into Bright from a few different ways. You can either be referred from another ambassador. You can sort of just find Bright on your own. You can come in through a Facebook ad or from the website. And these are things that the growth team cares a lot about. But we have enumerated, using an enum, all the possible ways that you can get into there. And this just lets us be confident that there are no other kinds of values coming into this like piece of data, right? It just allows, and then the database will enforce this for you. If you try to store something in the ambassador referral that's not Facebook or web or other ambassador, then the data will say, sorry, your data is invalid. Okay, this just helps you keep your data structured. Yeah, Pablo.
So that would be kind of like a drop-down box where you can only select from a certain amount of values.
Exactly. So let me show you. For example, here, this is the ambassador lead origination page. You have to pick what kind of ambassador are you. You're either a student, solar mom, street team, installer, or other. So if you tried to save something in the database other than these values, you just literally couldn't do it. And the software that was running with the data wouldn't know what to do with that thing. There are like a few other cases of this here. What's the best time of day to contact you? What kind of family? Blah blah blah. So that just allows you for things that are specific to your use case, so you can model them exactly. Okay.
Sweet.
All right. So now we do a little exercise. From all the types that you remember, which one would you assign to a person's name? String. Right, exactly. What about a person's age?
Integer.
So that was a little bit of a trick question on purpose. You almost all said integer.
Real.
All depends.
Real.
Yes, you could also put real, but a person's age is something that's going to change over time a lot. Okay? The data there is not actually their age. But what is the real piece of data?
The date of birth.
Date of birth. Exactly. Okay, so this is like a little lesson to teach that these pieces of data that are time dependent, you want to make sure that you can represent them exactly, and you don't require updates to your data every day. I don't want something to go through, okay, update everyone's age, update everyone's age. So you'd actually model age as a date of like when they were born, and then you would compute what their age was as a piece of derived data. What about gender?
Enumerated.
Enumerated?
No,
Boolean, no?
Boolean, yeah.
Okay. Yeah. So you could have Boolean. There's two options. If you say male and female are the options here.
It's 2016, guys. We're gonna have
You could say enumeration if you wanted to actually list out the things. But this is on purpose too. People care a lot about what gender they identify as. I would say just put it as a string, and it's going to save you forever. Not going to have complaints from people saying, I don't identify with any of the genders that you have enumerated for me. Yeah. What about phone number?
String.
String?
That could change a lot.
But it has to be input. You can't calculate it.
Yeah, you can't know it from something else. It is a piece of data. You definitely have to store this. Why didn't any of you guys say integer? Just curious.
Because you can use like this type or plus type.
Okay.
They have other characters.
Spaces.
I think it's international number if you have a plus.
Okay, so phone number, I've seen in Bright more than one time represented as integers, and a few problems with that is you can't express international plus, you can't express area codes, you can't express extensions if there's an extension from the phone number to like it's the person. So if you can't represent your data exactly, then string is usually your best option because it supports almost everything. What about zip code? What would you put for that?
Integer.
Integer?
You also need to be like wake up or minus 1, 2, minus 3, so you find it's a confirm.
Okay, well let's say, yeah, so you could, perhaps Max is saying that you could derive the zip code from a latitude and longitude. So he's saying the piece of data there is actually something different. I don't know if that's always true, but that's a really good point. I would certainly not represent zip code as an integer, and here's why. What's the difference between these two numbers? 1, 2, 3. and 0, 1, 2, 3.
Yeah.
And nothing, right? They are the same number, but they could be different zip codes, right? Okay, so we want to make sure that we don't lose any information by picking a type that can't actually express all of our values that we might put into this type. Another thing about using integers for zip codes would be that can you add integers together? Sure, you can add them, you can divide them, you can do lots of mathematical operations with integers, but you can't do them with zip codes. It just literally doesn't make sense. It's not representing a quantity or anything. It's actually just a code that the government has given. Doesn't have to be a number necessarily.
So it should be a string?
Should be a string. And I'll talk about that a little more in a second. What about a trace of someone's roof? So I think we talked about this already. Hopefully your database has something that can support this. So let's say that the use case here is you have a roof on Google Maps, okay? And you are picking points along the roof and you're tracing it. All right. How would you represent that in the database?
Location.
Hmm?
Location.
A location? Yeah, but we have more information there. Right? It's not just latitude and longitude. It's like a collection of those points. Right? I'm sorry? Enumeration? Enumeration can only have a certain set of values. You can only have, it's like a drop down on the website, right? So you couldn't fit, you need more data there than an enumeration.
So you said bounding box, but what is that?
A bounding box is basically one of these, but with only 4 points. It's the box around your.
What would be a bounding box with more points?
So a database doesn't have that. Okay. So this is a really interesting case, I think, because this is a piece of data that you want to store, and to us as humans, it feels like one piece of data, right? To a database, let's say this was a box. We could represent it as 4 points, right? That's fine. That would work. That would work perfectly. We store those 4 points. Everything's great. But this has like a variable number of points. So what I would do in this situation would either be to find a database that could do this. Not all of them do, but find a database that could. That's one option. Second option would be to actually store these in another table and reference them somehow. Okay? So each point of the path, put it as its own row somewhere else. That's another option. A third option would be to put this as a string. Okay, like we said, strings can do anything. And you just need to define what you want the format for this string to be. Okay, so let's say that the format for this string will be latitude, comma, longitude, comma, latitude, comma, longitude, comma, latitude, comma, longitude for the whole thing. Okay, that allows you to like store all your data. You don't lose any information about it. It's going to be pretty hard to query anything about that, but it's going to be hard to query anyway because it's like a weird shape. And, there's not like an Excel formula to like look up in a box.
Is there any way to store visual data?
Yes, there is. Usually you won't use a database for that. You would store that as like a blob of data, right? You have a JPEG or like a PNG file, and you'd store it on Dropbox or something. Or we can get into we can get into more of this later, but then you would store a reference to it. So the field would be a URL, okay, and then the URL would link to the image data. Any other questions? Cool. Yeah. So I just wanted to point this out as like there are times when we as humans think of one thing as a single piece of data, but conceptually, but in a database it has to be represented a little differently. You have to be really creative on how you store it. Cool. So we talked about zip codes a little bit ago and how we were going to represent them as a string because numbers don't quite capture them. They don't really feel like a number. You can't add them. They're more of like a code. there won't always be a type that exactly matches your data. Okay? So, for example, if we were to actually store someone's age, let's say it's an age at a point in time, we want to store that piece of data, and we use an integer to store it. Doesn't make sense for someone's age to be negative. Okay? Doesn't make sense at all. Doesn't make sense for someone's weight to be negative, or the weight of anything for that matter to be negative. So there would be maybe a positive integer type that we could use for this, but the point is that most databases don't exactly express directly what you want your data to look like. So usually when you model data, there has to be a step of validation before you actually write to the database. So if any of you have used this Ambassador website and you type in an email a@b.com and try to submit that lead, a@b.com is valid. Okay, ab.com is not valid. Okay, so this is a step that I've programmed into this website that before we store data. Actually, what do you guys think the type of the email field is in the database? It's a string. Yeah, it's a string. But there are some strings that aren't really valid email addresses. Right? If I try to send an email to ab.com, it's not going to work. It's never going to work. a@b.com, possibly. I don't want to go check if b.com exists and if a is a real user on b.com site, but I can at least do the check that there has to be an @sign, there has to be a dot something at the end. A@b will certainly not work. Come on, website. Oh, it does work. Well, that's a bug.
Well, if you put a space at the end, right?
Yeah.
It's the same. It's
Yeah.
not better.
I think our software probably should take the space off for you, but yeah, it's not a valid email address. So when you're modeling, you have this idea of validation. Your types aren't going to be able to save you all the time. You certainly can't store the name Steven into an integer type, but you can store 0, 0, 1, 2, 3, 4, 5 into an integer type, but you're going to lose the 0. It's just 1, 2, 3, 4, 5. So you do have this idea of validating your data before it gets into the database. And like I said earlier, and I can't stress enough that strings can do anything for you. You can always put your data into a string. I think this is probably why Excel and Google Sheets have chosen this model. You can always anything that you can type can be data. It's just not really great practice if you can help it. You want to give it a type so that the database can help you keep your data well structured. Okay, here's another example. Date of birth in 2017. That doesn't make any sense at all. You can't be born in the future, right? Maybe you are building a database for a movie that's set in the future, in which case this makes sense, right? So you need to give the context to your data, like we talked about earlier. What's the context? And then build your validation rules on top of that. Okay?
What happens when the date is different? Like in the US, they write the dates the other way around.
Great question. So the way that databases store dates isn't necessarily in any sort of locale. Okay, you see me write my dates like this a lot, even in emails and stuff, because it's everyone understands it. Like year, month, day. In English, they understand it. In Spanish, they understand it. The database stores dates in a similar way. If you want to present your data to someone in Mexico or the United States, then you can do functions on that date to extract the parts out and show it. So let me give an example of this.
Can you do functions on any data?
Yeah. So the database will have a bunch of pre-built functions of the types that they have. Okay, so if your database has a date type, it's also going to come with a lot of functions that you can run on that data to present it in a different format. Okay. Can you guys read that?
Select.
Okay, so we're not into SQL yet, but let me just sort of show you what this does. Today is May 3rd, okay, and current date is just a special variable that's of type date. It's a date type, and there's a function called date trunc, and date trunc takes a like how do you want to truncate this date? I said I want to care about the current week of this date, and so you might be able to see it down here. But it says the beginning is 2016 May 2nd. So that's a function that can run against your date. I don't have the functions memorized to like convert between different locales, but you can do that too. You basically say what order you want the month, day, year to come in, and then you can format it however you want. But that is sort of how you present your data to someone. That's not the actual data. The data is the date. And you don't really care about how the database stores that. You just care that it is the date that you're talking about. Make sense?
Yeah.
Same thing with like currency. You usually will put commas in your currency, like this, or it's the opposite in Spanish maybe. But
That's a great answer.
that's right. Okay, cool. So you might have like currency shown like this, but the database isn't going to store that comma. It's just going to have this. So that's sort of how you present your data. You have the data, which is 112300, and you have how you present the data, which might be a function that adds this like comma for you. Okay. And the database will provide a lot of functions like this to help you format it, or you can sort of write your own like you do in Excel. Combine a bunch of functions together and take the year part off, put it at the end, whatever you want to do. But pretty much most things that you can do in Excel or Sheets, you can also do in SQL. Just a slightly different syntax. Okay, so this is just going over what I said before. How do you pick a type for your data? You may pick the closest basic type that fits that your database provides. So integers, strings, reals, what else? A latitude, longitude. The best one that fits, and then you can add validation on top if you have specific needs for your data. It's a little different than what the database provides. I love these two links. They're like tricky things that people get wrong in data modeling all the time. So this one is falsehoods that people believe about names. So the first one here is that like people have exactly one name. That is that's a false statement. If you look at all the people in the world, let's see, people's names are not written in all caps. So if one of your validations was that you think it's like capitalized correctly, like that's probably going to be wrong. People's names are unique. You guys have probably seen this already. People have the same name all the time. People have a name, even, is like one of the assumptions that people make whenever they model data. If you're a baby, you haven't been given a name for a long time. Let's say that you were an abandoned baby, you didn't have a name for a year or something. These are all like mistakes people make when they don't think about all the possibilities of their data, right? So for us, I think we're probably okay to assume that people have a name, but I just wanted to point out like some of the stumbling blocks you can come into. This is another one about time. Luckily, databases provide a time concept to everyone, but some of the best ones I like about this is that time is always increasing. It doesn't. Like every year divisible by 4 is a leap year, and that's like just not true. Time zone differences are always an hour off. Not true. So all these like things, whenever you're like trying to mess with your data, most likely you're going to be wrong. So, which is why you always prefer to use the database types and functions that the database can give you. Cool. Okay, so we also touched on this a little bit before. I want to go over it again. So we talked about the age versus date problem. Okay? You don't store their age, you want to store their date of birth. Okay, now let's think about a data model that is used to determine whether a person can get into an R-rated movie, yes or no. All right. So, how would you check that?
By the year.
Okay.
So if it's under 18,
Okay.
you're automatically go to R-rated.
How many of you have been to a movie before you're 18? R-rated, yeah, everyone, right? Okay, so these are cases where your data might not be flexible enough to handle the real world, right? If you just straight up say people are not allowed to go into this R-rated movie unless they're under 18, that's going to keep all of us from seeing movies that we want to see. In the real world, people make exceptions. Okay, so instead of modeling, are you able to go to an R-rated movie? Perhaps as just like a straight check, is your date greater than 18, or your age greater than 18? You would instead check, is your age greater than 18, or is there a manual override on you? All right, so maybe another column that says you are allowed to go to R-rated movies, perhaps. That would allow the person at the terminal at the movie theater to let you go in, even though you're not 18, which happens as we see all the time. Make sense? There's another example of this. In Bright's data, we have a piece of software that runs and checks your credit score for our customers. If it's over a certain number, you're approved. If it's under that number, you are not approved. Simple enough. It seems like something we don't really even want to bend the rules on at all. Make sense? However, if I programmed it that way, and in the future, we change our rule. We make the score a little higher. Now it looks like all of our previous customers have been rejected. If we decide in the future to move that number up a little bit. So that is actually data in itself. The fact that someone has approved this project is the data. You need to store that because just deriving that based on the number isn't enough. Make sense? This is an example of designing your data to be flexible to change in the future. The same thing would happen with an R-rated movie being under 18. If the movie association changes that age to 17, now it looks like people got into movies they shouldn't have in the past. So any sort of action that happens that you're trying to model, make sure you capture the data. But also don't design your data to need to be updated every single day. So it's kind of a little bit of a balance there as well. Okay, so the next thing that we're going to talk about is entities. So far we've mostly been talking about columns, like individual cell in Excel, that you type a number or a string or anything into. An entity is like a database table. It is a collection of rows. It models a single thing in real life. Okay, so some examples of entities would be a person, a building, an E-gauge, a solar panel, a lead and Bright and ambassador, things that we have lists of, lots of rows of, that mirror something in the real world. Okay, so in the database world we call this a table. In Sheets it's called a sheet. In Excel it's called a sheet, I don't know. And so this is a table. It's the collection of all of the things of a particular type that we have. Every single instance of that entity is called a row. Pretty straightforward. And then every row is made up of columns. Okay? And then this is actually kind of important. A column has a name, a type, and then its actual piece of data associated with it. Without a name, you just have a number. It's like 4. Like, what does 4 mean? You don't know until you give it a name. A type, in Excel, the type of everything is a string. But in real databases, types are integers, reals, booleans, strings, etc. And then the data, what's actually stored in that column. Okay, can anyone give any examples of what some entities at Bright might be?
Client number.
I'm sorry?
Client number.
Client number. So an entity is a whole table. Do we have a database of just client numbers? Client, exactly.
Client.
So a client would be an entity, and then a client number would be a column.
Okay.
And it would be what type?
Huh?
What type of data would that be? Client number.
A string.
String. Yeah.
So ambassadors is an entity.
Ambassadors is entity. Client's an entity.
Ambassadors.
Master ambassadors. Yeah. It's actually not. But yeah, but that's a good point.
So master ambassadors is a column in the ambassador entity.
It's a Boolean checkbox of
Okay.
whether or not the ambassador is master.
Okay.
Yeah. That was easier for me because I was lazy. Anything else? We had 50 tables. There must be more.
Engage.
E-gauge? Absolutely.
Like a project.
Hmm?
Project.
Project? Yeah. We have e-gauge. We also have e-gauge sample, which is the list of the individual measurements from each e-gauge. We have a break zone, which is right now Guadalajara, Querétaro, and Mexico City. DF.
Type of ambassador.
What?
Type of ambassador.
Yeah. It's not quite a whole entity. It's an enumeration, but yeah, you're right. The reason we chose for zone to not be an enumeration and instead to be its own entity was because we want to know other things about that zone. We want to know what area it encapsulates. We want to know when that zone first became a zone for Bright. We want to know the name that we give to it. We want to know a lot of other things about it. So it's more than just a like switch, like a 1, 2, 3, 4, 5. It has a lot of more properties. We have things like CFE bill. We have like lead approvals. We have leads. We have lead documentation. We have credit score requests. We have credit score results. There are just like a lot of things that define what Bright is. All right, so do a little bit of a brainstorm here. If you guys could take 5 minutes or so and pick one of these entities and try to list out all of the columns that might be in that entity. Okay, so an example would be ambassador has an email. Email is a string. Okay, so that would be like one column. What else does like an ambassador have? Phone number, yeah. So actually,
Contact information, would you put all in one column or?
you could. Usually you don't. We'll talk about how you'll do that in a little bit, if you wanted to. Well, let's just think about the individual pieces of data that you would put for one of these. So, do you guys each want to pick one? Can you say what you're going to do? Spend 5 minutes writing them down, maybe, and then we'll go over them. Gabby, can you do installer?
Guess what I was doing?
Is that what you're doing?
Yeah.
Okay, good, because I don't know what that is, like all entails. So I want to hear from you.
Ooh.
Do you know what I mean?
Just putting basic stuff there.
Okay.
Do you want me to put like more complex stuff?
Anything that you think is important
Or the
to know about an installer.
Sorry, stop.
So what I'm going to do is have you guys list out what you have, and then I'll show you what we actually have designed for each one of these as well.
Los instaladores no tengo idea. Juego de Vitaluz. Seguro tienes una projects que son una Vitaluz. O sea, cosas que cerraron que tuvieron Vitaluz. No sé si es una cómo.
Pero porque aún no estaba
No tengo nada que ver con nada. Pero pues sería. No sé. For example, an expert on that, consultant,
Mhm.
as leads under the ambassadors.
Okay.
And
Yeah.
I have a question to how
So that's what we're about to get to. It's a relationship between entities. Okay. So maybe just point out that they have these sort of things.
So we have like the URL.
Yeah, it's kind of like that. But whenever it links between two things in a database, there's a way to make a link that we're going to talk about in a second. So maybe just point out that they have those things, and then
It can be like this. I use like the client, and so I have like the email, phone number, address, and stuff. But the energy consultant can be also
great. So a client has an energy consultant.
but it's a column or an entity.
It is an entity, but it will have a special kind of column that's like, I'll call it a link for them, that links two entities together. Okay, so just these are all entities. Yeah. There's more, but these are just like some examples. So what these guys pointed out is if you know that some viewer, if you pick lead for example, you know that a lead has an EC associated with it. Maybe just make note of that, of how you might, of the things that are associated, and we'll go over those and how you represent those links between entities here in a second.
So you can have within an entity can have a column with another entity.
Kind of. Yeah. It's a special kind of data type that I didn't tell you guys about yet.
Okay, it's more complex.
Yeah, I guess it's more complex. What about the Boolean? It's either true or false, yes or no, on or off. You can only have two values. And your trigger? What? Your triggers? Or integer? 0, 1, 2, 3, 4, 5, 6. Dice roll, no? Okay.
No.
What was no?
No can only be one value, but you can add it to other values. You can say like a integer that's null. So it can be numbers or it can be null. And it's usually used to represent like or like we don't know, like 0, or like this sort of. But like if you had a date of birth column and it said date, like that means that you have a date of birth or that we know what it is. If it's null, it probably means that like this is data that we don't know what it is yet. So you could put a 0 date, like at time 0. But then you have to have stuff everywhere that knows that it's a special date. Like that no one can be more than time 0 that you know. So it's a way to sort of say, I don't know. Or this doesn't apply to this thing. For example, when a lead doesn't have an EC yet, its EC link is null to start. Alright, cool. Does anyone want to offer up one of theirs that they did? Yeah, Gabby?
Okay, so I have an installer. I didn't put that much. I put installer like head,
Okay.
which is like the main installer, which we lead with.
Okay, what type is it?
String.
String?
Yes.
Okay.
Email of installer string. Phone number. string, web page string, price per watt, integer,
Okay.
Why not?
a number of crews, which would be an integer.
So this, there would be a row for Marsum, Econologica, ARDC, not for every single person in that company. Right?
Exactly.
Okay. Cool.
Can that be like enumeration as well? If you have a list of all the installers that you work with, then you put.
Good question. So it could be an enumeration. We have only a few installers right now, so it would make sense maybe for us to have an enumeration.
But
I would
you can
say looking forward, we want something that we can just add an installer to. We don't need to change the type, because every time you add a new thing to an enumeration, it's like a different type. You know what I mean?
It's not that easy.
Well, it's not that easy, no. But if you said, it actually is fairly easy. But we want to store more things. We want to know more about an installer versus just what company name it is. We care about when that installer became, right? What projects do we have? Things like that. But you can't associate a type with other data. You can only associate data with data. Which is what we'll see in a second. Okay, Gabby, that was good. Anyone else have another one they did?
I did easy.
EC?
Yeah.
Cool. And what do you have?
I got mail string.
Okay.
Phone number as well as string. Cool. Leads and expert ambassador, which is the link you said.
Yeah.
As well as clients.
Okay.
And the source, I didn't know. Like, would it be also another entity?
Source. What would an example of a source be?
So an ambassador or from the web page, or that would be.
Yeah, that would probably be an enumeration type. Just to say like how the ambassador got in contact with like
And client number, which is also an enumeration.
This is a property of the EC.
Actually, no, that's actually a property of the client. That's all I got.
Okay, cool. So I didn't have an example for installer since we haven't built any installer software yet, but I do have EC. So let me pull that up. Here's what we have. So we have two IDs for the EC. Let's ignore those for a second. Well, we have a timestamp. So when did they become an EC? That's a piece of data that we care a lot about. Email. We have their full name and we have their preferred name. Okay, their full name is their legal name that they talk to clients with. The preferred name is what we email them as. For example, Juan Ignacio versus Nacho. We want to be able to call him Nacho in emails that we send. Last active at. This is the last time that they log onto the website, which it's not a real thing as the real world, but something that we keep track of in phone. So you pretty much got it exactly. We don't have EC source, and we also have like an extra created at timestamp field.
Like EC source, who referred to EC?
That's what you said, right?
Yeah. I meant the client number.
Okay. Cool. Anyone else want to offer up their try?
When you're tracking how the EC is doing, like how many leads have they signed or how many they have approved, is that another entity? Because this is like all the info that we have from the EC, right? Where can we get all the other info?
Good question. Can we?
Or is that
Can we get to that? Can we get to that in a second?
Yeah.
Yep. Anyone else want to try? Yeah. Right.
I did a lead.
Okay.
The service number as an integer.
Yeah.
Then there should be the image of the invoice.
Okay.
Like I do that as a boolean that can check like true or false if there's a file.
Okay.
Like that's JPEG or any other.
How do you know what file it is?
You just, you would just have to check if there's a valid image file type.
So it's like true or false of.
If
Is
there's
it-
a
is it
JPEG or
Okay.
MPG or something else. Then
What is the image of?
what do you mean?
The
Like-
CF.
Yeah, the CFA.
Okay.
Then zone enum,
Mhm.
potential client name string.
Yep.
Family enum.
Okay.
The phone number string. Email string with conditional values. That would be characters at characters.characters.
Yep. Cool.
Then reference from other client enum that come from past leads name and customer number.
Okay, so that one couldn't be an enum because
It varies.
it varies, yeah, and over time that will change.
Uh-huh.
So that's
Yeah,
actually would be a link. We haven't
A
talked
link.
about these yet, but yeah. Cool. So you picked a hard one. Let me show you what our lead table looks like. Okay, so we have an ID for it. Don't worry about that. We have a link to the ambassador. We have when the lead was created. We have what kind of type the ambassador was. Name, email, phone, best contact time, CFE, bill, link to an image.
So that's all the ambassador platform, right?
Yeah. Notes about them, if the ambassador types in any notes. Who the EC is, a link to an EC, a customer ID, you said that, a link to a team of an ambassador, additional data, don't worry about that, the CFE name and RPU, and a link to another lead that was the person who referred this lead. Okay, so we're kind of seeing that like
The last one is enum as well.
it's called a reference type or a like foreign key, but I'm just gonna call it link because it's a lot easier to talk about that way. And we will get into like how SQL calls it next time. So you guys are seeing that like through all of these things, the pieces of data are like usually pretty simple. What's more important is the links between your data, right? That's where a lot of the information is in a data model. Okay, an EC has a bunch of leads, but also an ambassador has a bunch of leads. A client has like a lead associated with it. That lead maybe has a contract. That lead has approvals associated, has documentation, credit score. The meat of any data model is how all of your entities interact together, and that's when it gets hard. So which we're going to go into next. Sorry, before we do, one little thing on validation. We talked about validation at an individual column level. Diego was talking about how an email address needs to follow a certain format. You can also have validation that is present at an entity level. Okay, so for example, web leads are not allowed to have a referral linked, for example. These are just like maybe things that aren't captured in one particular column, but like validation that we want to put across the whole entire thing. If I'm trying to think of some other validation. If you're an EC and you submit a lead, then your ambassador link has to be null. If you picked your like type to be EC and then your ambassador has to be null. So these are things that like multiple columns that are dependent on each other. So you also, whenever you create things that write into your database, want to do a few checks on your data to make sure that they make sense. So here's a few examples I had. If we had a person and their mother, the person's birth date can't be before their mother's birth date. Like that's just like an impossibility. Each of their birth dates might make sense, you know? They're in the past, they're of like a reasonable age, but if we had a link that says the mother is, you can't pick a mother that's younger than you. It's like weird. For a bright system, might have two fields of when it was interconnected and when it was installed. It can't be installed after, it can't be interconnected before it was installed. That's just like a logical impossibility. These are things that the data like looks right, but we know to not be true. So this is when the software team builds stuff. A lot of the checks that we have in place when you try to submit data, we want to get it, we want to catch the error very early before it gets into the database and tell you about it, versus noticing it later, going back, sending you an email, hey, can you fix this? Sort of how the process goes right now, right? But yeah, this is like entity level validation. Keep all your entities and their links, as we'll see in a second, logically possible. Okay, so before we get into links that I've like alluded to, I want to talk about something called primary keys. Okay, primary keys are something that can uniquely identify a row. That way you can update that row, you can change it, you can delete that row. You have to have a way to refer to it, right? Does it make sense? So right now, what is the primary key for a client?
Client number.
Client number, okay? In the theoretical sense, it's not really a primary key because it's changing. Sometimes the client number changes when the EC accidentally generates a second proposal, for example. For ambassadors, what is the primary key? How do we uniquely
email address.
Yeah, so email. Email is how we like.
Phone number?
Yeah, phone number would be a way too, but not all ambassadors enter their phone number like immediately. Right, so they leave it blank, and if you have two of them that are blank, then you can't uniquely identify them. Okay, so whenever you're designing data, you need to pick a way that you can uniquely refer to this thing, and it can't change because these keys are how we're going to build the links. So with ambassadors. When ambassador submits a lead, we put the ambassador's email into the leads database on sheets. I mean, you've seen that. Yeah. What happens if an ambassador gets a new email address? What? They lose all their old. They lose all their old leads. That sucks, right? So email for ambassador is actually a pretty bad primary key because it changes. It will change eventually, and it's something that the ambassador actually cares about, something that they will want to change. So we need to find a different key for an ambassador to uniquely identify it. And how do we do that? You could maybe pick their RFC number. That's pretty unique. It shouldn't change. What happens if you have someone who doesn't have an RFC, right?
Could you assign
Like me, I don't have one.
Can you assign an ID for the first ambassador icon? It's
Like a
00001.
Yeah.
Yeah, like a customer number and ambassador number.
Cool.
Or just have a username.
Yeah, username too. People might want to change the usernames eventually, but yeah, that's a really good idea. Pablo, you had a question?
Yeah, what if you could create that unique ID?
Yeah, exactly. So the only real way to do it is to create it for them, right? And use that thing as your link. If people get to create what their primary key is, or they have some attachment to it, or something, usually they want to change it in the future. They change their mind. Humans will be humans, and they're going to change their mind. So the only really good way to do it is to generate them one. Okay. The easiest way, as you pointed out, is to just give them a number that counts up from 0. Okay. So the first ambassador is number 1. Second ambassador is number 2, 3, 4, etc. You're never going to run out of numbers. So they don't care. If you don't show them what their number is, they don't want to have it changed. They don't care, right?
So the referral link as well. That's a number that we give ambassadors. That's
Yeah. So I was gonna say, for those of you who have seen some of these numbers in Bright's system, you'll notice that they don't just count from 0. So let's look at this lead database. Okay, so we have here this lead ID. This is what the software team has decided we should use as the primary key for our leads. Same thing with ambassador. They have this super long number. Okay? The reason we do this instead of just counting up from 0 is because if someone were to find out, usually you can see these IDs in URLs and stuff. So like, okay, so here we have like the EC website and someone's lead. This is customer 2290. They have this long lead ID here. You can see it. It's like on the website. It doesn't really matter what it is, but you can see it. And if you just count up from 0, you're sort of exposing information about Bright to the world. Okay? Solar City can come into Bright. They can say, I want to be a Bright customer. They get number 5,000. They're like, hey, Bright has 5,000 leads. And they know something about us. You can also start to guess. If I knew that this is a lead, then I probably know that if I add a 2 here, that's also going to be a lead. This is just going to never work. So then you can also start to find ways into like hack a system. So what we did on the software team is actually we do count up by 0, but we have a large mapping. 0 maps to some number, 1 maps to some number, 2 maps to some other number. And that's how we pick our IDs, so that whenever we show them to people, you can't see. Like only we know that mapping, so you can't actually see how many leads we have, how many ambassadors we have, how many active customers, just by like looking at these URLs. So for all intents and purposes, you should just pick something like that, a number that counts up, as your like primary key, your unique identifier for your data. But at Bright, we didn't do that because we wanted to be a little bit more secure than just the default way of doing things. You can think of these as counting up in like some weird number system. So that's primary keys. And primary keys are, like I said, how you uniquely identify, but also how you uniquely associate entities together. Okay, so we're going to talk about relationships or links, as I've been saying so far, which define how our entities interrelate. Let's skip that. So I don't have very good slides for this. But can I erase this?
Yeah.
Thanks. So for those of you who have seen some of Bright's like lead database, we have leads, and we have also an ambassador list. Okay, and in the past we've used emails as the primary key. So whenever you write an entry into the lead database, it has, we talked about name, it has email, it has like ambassador email. Okay? And in this ambassador email, if it matches someone in the Ambi, that sort of makes a link between them, sort of implicit. So we do this with emails for ambassadors. We also do it with customer numbers. And there's another table that says what EC gets like what lead, and it's linked by customer number. Okay. So for all the reasons we talked about earlier, this is like not a good idea. An ambassador can't change the email. The customer number better not change, otherwise we'll have problems. All of these things lead to problems. So instead of putting ambassador email here, we're just going to simply change this out to be our ambassador ID. Okay, so let's call that 1 in both of these. We still need the email, right? That's still a piece of data that we care about. We're just no longer going to use it as our primary key. Okay?
Did you use email before we had an ID as a primary key? Before
No, we didn't. So
we always had the Ambi ID.
The software team did,
Okay.
because we knew we wanted it long term, so we created it from the beginning. And then what we did is for all the emails we found in here, we would make them a primary key, and we did something else to make that work. We also made sure that this is always unique. and we don't let you change this either. Okay, so we sort of treat this like it's a primary key in our database
But it's
but it's not. We treat it like it's a primary key because we know it goes into Google Sheets. It's going to be treated as a primary key. This is what we have to do to like keep Google Sheets working while we continue to build software. Okay, so instead of linking them by email, we link them with their IDs. Okay, so this here is a link of an ambassador to, or a lead to an ambassador. Okay, but an ambassador can have like a lot of leads, right? So we can have this. Okay, so who was doing the Ambi design earlier? Yeah, anyone? Okay, so in the ambassadors, you might have recognized that there's like a link to the leads that they had. No. Okay, but there is, right? You would agree that ambassadors do have leads. There's no column in the ambassador table that like links to a lead, right? Would you agree? There's no link column here. The link is on this side. Okay. Why is the link on this side? Why isn't there a lead ID link on the ambassador?
Because
great, like,
since a lead can only have one ambassador, so
right.
It's just easier.
So
yeah, because the Ambi can have a lot of leads, and the client can only have one Ambi.
right, exactly. Okay, so we can't have lead ID here because then an ambassador can only submit one lead ever. Right, Max would not be happy. So we put the lead, the Ambi ID over here instead of the lead ID over here, and it allows us to have what you call a 1 to n relationship. Okay, so for every Ambi, there can be 0 to n leads, as many as we want. Okay, but there can only be one Ambi. Did you guys agree?
Mm-hmm.
Okay. What would you call the relationship from lead? So, this is Ambi to lead relationship. This is 1 to n. What would the name for a lead to Ambi
1 to 1.
relationship
B, N to 1.
One
N
to
to
one.
1?
Oh no, 1 to 1.
1 to 1, right. 1 to 1. Okay, so every lead has to have an Ambi associated with it. Okay? What if this column here, Ambi ID, right now it's an integer, it's 1, 2, 3, 4, 5. What if we said it's an integer or null, like a nullable integer? So we can have a blank here, or you might see it as like null in SQL when we do it. What kind of relationship would that be?
One to zero.
1 to 0 to n.
It's like, I don't know if there's a real name for it, but it's like 1 to 0 or 1. Right? So you can have an MD, but you might not. You can have at most 1. Okay, so this process here is defining the cardinality. It's called, in mathematical term, the cardinality of your relationship. Okay, so 1 to n means that this relationship can have 1 here to 0 to n here. This one, 1 to 1, that they're exactly linked together. 1 to 0 or 1 means there might be a link, but there might not be a link, but only one. What about Ambi and Ambassador team? Let's design what Ambassador team looks like. Okay, I'll get us started and I'll give us a team ID. And name. What else do we need? So, one. This is Steven's team.
MBID per team member.
Team member.
Like, yeah, like you have an MBID for every team member.
So here. Okay, and so let's say I'm on my own team. How do we add another person to the team? Another row here.
Oh,
Another team. This is the entity is team here, and the entity is M here. How do we add another person to the team? Let's add Diego. Okay.
You would repeat the
No, another
team's name and the other field and then at the other end of it.
I'm sorry.
Wouldn't you repeat like the team's name?
Team's name.
Well, yes, a team name.
This is the Ambi team's name. So this is like Steven's awesome amazing team or something.
I would repeat the whole fields except for the.
Okay. So here we have the.
The same team ID.
This is the team ID here.
That's right.
Okay. This is the name of the team. Steven's team, and then the Ambi ID is number 1. Okay. So you're saying do 1 Steven's team, 2.
And then add this. Yeah.
Okay. Okay.
Or you can add team's ID over here. Another
Yeah,
one is
we can add team ID over
Yeah.
here. And then this
One,
is
one.
on 1 and this is on 1 too.
Exactly.
Which one do you guys think is better? Why?
because it can count if the team ID is out.
Or you can organize it by tab.
I'm sorry?
Like you can organize it by team ID in the same table.
Yeah, you could do that. You can also do it here too, right? You probably could. So what happens if I want to go update the name of my team? And let's take this example, where we have team ID 1 and 2 rows.
You repeat more operations.
Yeah, I need to
So
go.
have a lot of
I have to
data.
go. I have to go update these all. How do you count how many teams that we have?
So not the team ID.
Yeah. You have to like count the unique team IDs, not the number of rows. Doesn't associate with the number of teams. So okay, so this is we could have done this to begin with. This is a 1 to n relationship this way, right? Okay, and sort of how you build 1 to n relationships generally is that in the 1 side you put the ID of the n side of the relationship. Make sense?
Yeah.
Because you can have only 1. An Ambi can only have 1 team. All right.
Isn't it the other way around? 1 to n.
1 M. Oh, sorry. 1 team to n Ambis. Redo that. So,
Every ambassador
yeah.
has
So every team has n ambassadors. Sorry. So then on the inside, you put the ID of the 1 side. Do you guys see why that is? I'm not doing a great job of explaining why, but hopefully, like logically, that makes sense.
But what happens when a team member becomes an expert ambassador and now he has a team ID? Do you change the past team ID to the new one?
Okay. So we have a team. Let's first. So let's take this MBID out. We don't need it anymore. Okay. How do we say who the expert ambassador? Actually, let's do this first. How do we say who the EC is for this team?
We
add a team ID to the EC.
Yeah,
Every-
EC column on the EC database table, the EC table, you can add empty.
the team ID.
Yeah, you add the team ID.
So first, let's go back. What is this relationship? And how many teams can an EC have? Okay, infinite. How many ECs can a team have?
One.
1. So we have another 1 to n relationship, right?
Yeah.
So can you apply the formula that we've been doing? Where does the link go? In which of these?
On the MB team.
Yeah. So we have an EC ID here, okay? And this tells us, I'm just gonna use a larger number. So 7 can like link to here. We can have another team, right? So Andres, that also is the EC number 7. Okay, so now we can have multiple, and now we have 1 to N, or 1 EC to N teams, and we have a 1 to 1 this way. Every team has an EC. Cool?
Yeah.
Now let's add expert ambassador. Okay, every team has 1. Okay? Exactly 1?
Yeah.
Yep, 1. Okay, so there might be an EE table.
It's a one-to-one relationship. But not
Not
from the
every
other way.
MB is an E. Is
Has it?
No,
oh
Every
so-
MB has-
yeah.
yeah.
great.
Every MB has an EE, but an EE can have a lot of MBs. As
Yeah,
many
but
as
only
he
Only
likes.
one MB team.
Yeah, only one MBT.
Okay, so let's do EE. Now
They don't have.
now what's the relationship between EE and MBT?
1-to-1.
1 to 1. Okay. This 1 to 1 means the link can go in either of the tables. It doesn't really matter that much, but you should think about for this relationship, what makes more sense. So would you guys say it makes more sense for the team to have an EE or for the EE to have a team? Yeah, I don't think this one really matters, but in other cases,
Verbally, it sounds like you have a team, but maybe there's like, I'm trying to think, there's maybe a weird case in the future, where maybe, like probably not, but maybe he like breaks his teams for some weird reason.
Mhm.
So maybe giving flexibility to assign different tutor and teams having different might be like some preferable.
yeah, so I would say, me personally, this is actually just preference, doesn't really matter that much, that the EE is a property, it's a column of the team. It's like what defines a team, because if you say, I'm going to change the EE of a team, you think, I'm going to change the team. You don't think, I'm going to change the EE, okay, right? So that's sort of how we thought through where this goes in this data, but for one-to-one relationships, doesn't really matter, okay? Let me show you one concept that we have as a one-to-one relationship that hasn't come up today at all, that you asked about earlier, was you asked, can you put the address as like its own like one column, okay? And you can, but how you normally do that is you make a link to another table of addresses, okay? That way you only define the structure of what an address looks like one time, and then like anything that needs an address can link to it. So like an EE might have an address, a project might have an address, an eGauge might have an address. So that way you only have to define all of the types and the validation for this kind of thing one time. For us, an example that we have like that, we call it bright user.
So for Bright to have a link, well, for entities to have a link, you need a primary key, right?
Yeah, you need a primary key because the primary key is how you link them together. Remember the things we talked about primary key? It has to be unique for that piece of data. If it weren't unique, you would like make links that, I don't know, they like you go to multiple. It doesn't really make sense anymore. You don't know if it's one-to-one or one-to-n. You could possibly do that. I would say it's a bad idea. But let me go over this. So we have this idea of bright user. And what we wanted to do here is we wanted to have all the users of Bright software in one place. We're going to be able to look up them all. We say that all Bright users have an ID, a user ID, excuse me, they have an email, they have a password, they have a nullable phone, so maybe they have a phone, right? Maybe not they have a phone. And we say, or they have a name, and they have a preferred name, like how we send them emails, So this is what we say are all the common things that someone who uses a piece of Bright software has. And so if you look, actually, whenever we get to this next time, at the EC table, it doesn't have email in it. It doesn't have name, preferred name, anything. It doesn't have those fields. It just has a link to the user. So you have that for EC, you have that for Ambi. They just link to this. We have that for we will have it for installer. We have it for the ops team. We have it for like a lot of things that we just want to provide. We don't want to redo all this work that we did to make this one thing. So we do it for Bright users. For invoicing, we also do it to we actually do address. So your invoicing address is like a table. It has like your street number, like what zip code you're in, and then when you make an invoice, it's between Bright, Bright and that user, or like the other way, an installer and Bright, and you just have like who is the payer and who is the debtor links to the other database. So we don't have to rebuild those things all the time. Okay, so this is one-to-one. Every EC has exactly one user, but not every user has one EC because they could be an Ambi, it could be an installer. So this way, it's 1-to-1, and the Bright user to EC is like 1 to maybe 1 to 0 or 1. Okay, so there's one type of relationship that we haven't talked about yet, is end to end. Okay, let me think real quick of an idea or what this might be. Actually, let me look at the database so I can see which ones we have. These are less common, but really useful to know how to model them. Okay, so we actually don't have any yet, Bright, but bear with me for a second. Imagine that an Ambi team could have multiple. No, imagine that an ambassador could be on multiple teams at the same time. Okay.
How about if it's a client that has multiple
Yes, but the property only belongs to one client.
But with the address, with the different address, right?
So what are the two? One owner with?
Many properties, like many houses.
Okay.
So there's two addresses, right?
Okay. So all right. Yeah. I'll go with that. So let's say our entities that we're going to link end to end are. This didn't quite work.
Sí, pero tienes que saber cómo es.
Let's do the team. I have a hard time like getting an example that's easy to explain. So let's imagine that you as an ambassador can be on multiple teams at once. Whenever you submit a lead, what you do is you actually like pick what team you want this lead to be for, and then you submit the lead. Okay? So over here we have Ambi, and here we have Ambi team. Oh, let's just call it team. All right. So before we had each ambassador had a team ID that linked over here. That's not going to work anymore because we kind of need this team ID to like link more than one place. Okay, and also the team. Yeah, the team, same thing. The team's going to have all other Ambis as well. So we have this like explosion of stuff happening here. Any ideas how we might be able to resolve this problem? Yeah?
Could you do a column that's like number of team IDs, and then based on that, create a number of columns in the Ambi database, and then for each of those columns, link to an ID.
Yep. So, what Max is saying is that we can have a team ID, we can have a team 2 ID, blah blah blah, as many as we want, as the number of teams that we want to allow you to have. Okay, so like this column can point here, this column can point here. Yeah, that works. So now we have team has multiple ambassadors, and an ambassador can have any number of teams. However, the problem with this is that you can only have a fixed number of teams that you're associated with, right?
Well, it's actually what I was asking is if you have a column that specifies the number of teams, so it's like a variable column.
Okay. So I'm gonna take your idea and twist it so that it would work. You guys remember I mentioned earlier that you can shove any kind of data you want to into a string. Okay, something that we could do is make a column that's like team IDs, and we make a convention that we're going to make a string that has commas between those team IDs. Okay, that works. Or 1, 2, 3, and this is the column that's like the number of team IDs. So you can look at this and then link to all those teams. That's one way to do it. It's a little clunky. It's kind of hard to query if you imagine writing like count if on this. It's going to be a little hard, right? Any other ideas? The two that we have do work. It's a perfectly valid way to model your data. The like pure way to do it. Oh, do you have an idea?
It's a crazy idea. Could you add another table that connects those entities with a third entity, which is just one that you create?
Yep. So that is generally how it's done in databases. Is you have a table. I wouldn't call it an entity. It's sort of modeling a link. It's a table that tells us how to connect these two things together. So let's take the team ID out of Ambi entirely. Okay, and let's make a team here that's like Ambi's on team or something. Okay, and the things that are going to go in here are going to be the team ID and the Ambi ID. Okay, does it make sense? So now you can look at this table and you say, what are all the teams that a particular Ambi is on? So what teams is Ambi 1 on?
1, 2, and 3.
So Ambi 1 is on teams 1 and 2. Follow?
Yeah.
Okay. And then Ambi 2 is only on team 1. And what Ambis are on team 1?
1, 2, and 3.
Okay. So what we sort of did was we know how to make one-to-n links. We know how to make one-to-one links. We don't know how to make end-to-end links. But instead of making an end-to-end link, we made a 1 to n and a 1 to n link here. So that if you take them all together, you get end-to-end. Okay, so to query this, you have to sort of do it in 2 steps. You have to ask, if you care about what teams are in Ambi on, you ask for all the rows here that match this, and then you have the list, and then you go get them over here. And then the other way, what Ambis are on this team, you go here, you find a team, you have now a list of Ambis, and you go over here and you get all the Ambis. And I'll show you guys how you can, this will be the most advanced query that we do next time, but I'll show you how you can connect this all together in chains in SQL. SQL lets you go here to here to here, and then you can go from Ambi to their leads, to the lead to the client to the house. And show you how to sort of like put them all together, getting exactly the data that you need. Cool. Any questions? Any questions here? Awesome. So this is the basics of data modeling. Like I said, the hardest part is figuring out what your relationships are going to be. They basically define how the company works. by themselves, they're really not that interesting. You saw like a lead has a name and email. Yes, these are all things that we know. How do we link them together? Okay. I'm going to show you one more thing before I let you all go. Is basically links that to two things that change over time. Okay. So right now, usually a lead has one EC. Okay, so that's going to look like if we have lead here, it has an EC ID that links to an EC, right? That's how we decided to do it because this is a 1 to n. An EC can have many leads. What happens if you want to show that like the EC for this lead can change over time? You don't really need to know that, right? But it would be nice to show a customer, if we had a customer website, hey, you used to have Luis, but now you have Paula as your EC. If we just change this piece of data, we change the EC ID, we lose information. We like lost the fact that it used to be Luis. We only know that it's like Paula, and that's all we know. Okay? So you can model links, 1 to n links, that change over time, the same way that we did the end-to-end relationship. Okay? So let me show you that real quick. So if we had a like EC lead history, we have an EC ID, a lead ID, and then we're going to have a date in here of whenever it happened. So
it's a big table.
It will be at least as big as the number of leads because you need one entry in here per qualified lead. And then you'll have an additional entry every time that an EC reads. Okay, so it will be about the same size as the lead table, probably. Like, how often does a lead get reassigned? Let's say 50% of the time, then it's going to be 50% bigger. Yeah, so not unreasonable.
So that happens when an EC leaves, for example.